All right, let's get right into it. This is a technical reference for UML use case diagrams. We're not going to cover the history or the high-level benefits. Instead, we're focusing strictly on the syntax, the core components, and how to use them correctly.
So, here's our plan. We'll start with the core components, then dive a little deeper into actors and use cases. After that, we'll cover generalization, and we'll wrap up with the big ones, the include and extend relationships.
Okay, let's kick things off with Section 1, the fundamental building blocks. You really need to get these 4 core components down because everything else builds on top of them. Before we break everything down piece by piece, let's just take a look at a complete diagram. This one's for a mail order system. You can see all 4 core components right here. We've got the system boundary, which is that big box. We have the actors, those stick figures outside, the use cases, or the ovals inside, and of course the lines connecting them, which are the relationships. Now let's dig into what each of these actually is.
First up, the system boundary. It's really just that simple rectangle you see, but its job is absolutely critical. It defines the scope of the system you're modeling. Think of it this way. Everything inside that box is your system. Everything outside of it isn't. It's a hard line that prevents any confusion about what you are and are not building.
All right, next up is the actor. An actor is basically any entity that's external to your system but interacts with it. And here's the key takeaway, something people often get wrong. An actor represents a role, not a specific person or thing. It could be a customer, not John Smith. That role could be a person, sure, but it could just as easily be another system, some piece of hardware, or even something like a scheduled event. So, how do we draw one? The standard notation is just a simple stick figure. You write the name of the role, like administrator or payment gateway, right underneath it. And notice its placement. Actors always go outside the system boundary. Why? Well, because by their very definition, they are external to the system. Okay, so what's happening inside the system boundary? That's where we find our use cases. A use case is just a specific piece of functionality the system offers. It should represent a goal that an actor wants to achieve, and it has to provide a real observable result to that actor. It's not some hidden internal process. It's something the actor interacts with to get something done.
The notation for a use case is an oval. Simple enough. But here's a pro tip, and it's an important one. Pay attention to how you name them. The best practice is to always use a verb-noun phrase, something active, like add course or process payment. This is really important because it keeps the diagram focused on the actions and goals the system provides. And finally, how do we connect the actors to the use cases? With an association. It's just a solid line between an actor and a use case. That line simply means this actor participates in this use case. It's the glue that shows the interaction between what's outside the system and what's inside.
All right, on to Section 2. Now that we have the basics down, let's look at some of the nuances of actors and use cases to make our diagrams more precise.
So not all actors are created equal. We often distinguish between a primary actor and a secondary actor. A primary actor is the one who kicks things off. They initiate the use case to get something done. A secondary actor is different. That's an actor the system needs help from to complete the use case. Think of a credit card system as a secondary actor. By convention, you'll usually see primary actors on the left of the diagram and secondary ones on the right. And again, just to hammer this home, actors do not have to be human.
And this is a perfect illustration of a key concept in UML, abstraction. The notation is always a stick figure. I don't care if your actor is a human user, another API, a legacy mainframe, or some AI agent. It's a stick figure. Why? Because we're modeling the role it plays in the interaction, not what it physically is.
Okay, Section 3. We're going to talk about generalization. This is a really powerful tool for cleaning up your diagrams. It's all about handling shared behaviors to get rid of clutter and make things easier to read. So take a look at this diagram. We've got a customer and a sales agent, and you can see they both do a bunch of the same things, right? They both list products, order products, accept payments. This leads to all these extra lines on the diagram. It's redundant, it's messy, and as the system gets more complex, this kind of thing becomes a real nightmare to maintain.
So how do we fix that? With generalization. Look at this revised diagram. We've introduced a new, more abstract actor called purchaser. We connect that actor to all the shared use cases. Then, our more specific actors, the customer and sales agent, simply inherit from purchaser. You see that arrow at the hollow tip? That's the generalization relationship. Instantly, the diagram is cleaner, simpler, and much easier to understand.
And this isn't just for actors. You can apply the exact same principle to use cases. Here, we have a general find product use case, but maybe finding a book is slightly different from finding a CD. So, find book and find CD can be specialized children of find product. They inherit all the basic behavior and relationships from the parent, but can also add their own specific steps. It's a great way to model variations of a core function.
All right, on to our final and maybe most important section. We're going to break down the include and extend relationships. Now, these are absolutely essential for modeling any kind of complex behavior. But honestly, this is where a lot of people get tripped up. So let's make sure we get their meaning and usage crystal clear.
Let's put these two side by side, because that's the best way to see the difference. Capsule include is for required behavior. The base use case is literally incomplete without it. Capsule extend, on the other hand, is for optional behavior. The base use case is perfectly fine on its own. And the other critical thing to burn into your memory is the arrow direction, because they're opposites. For capsule include, the arrow points to the required piece. For capsule extend, the arrow points back to the thing it's extending. Let's look at some examples.
Okay, here's a perfect example of include. Think about it. Can you change employee details without first finding that employee? No. Can you view them? No. Can you delete them? No. You must first find the employee details. Because that step is mandatory and it's shared by all three of these other use cases, we extract it into its own Find Employee Details use case. It's required, reused functionality. And look at the arrow. It's a dashed line pointing from the base case to the piece that's being included.
Now let's contrast that with extend. The base use case here is return book. A user can return a book, and that's a complete, successful interaction. The use case is done. But what if the book is overdue? Under that specific condition, an optional behavior might kick in, issue fine. This isn't required every time. It's an extension of the normal flow. And again, look at that arrow. It points from the optional extension back to the base use case it's extending.
So, there you have it. We walked through the core syntax, the components, and the key relationships of a UML use case diagram. The technical reference is complete. So the real question now is for you. Think about the project you're working on right now. How would you use what we just covered to model its core functionality, to define its boundaries, and to clarify who or what interacts with it?